Hello, welcome. This is our circuit number 7, the house alarm with zone indication. As you can see here, we have our latching circuit which will indicate the zone that has been violated, and here is the output to drive our siren, and here are the zones. So we have zone number 1, zone number 2, zone number 3, and zone number 4, of which zone number 4 is the entrance door. Before we begin, we are going to have our script reading as usual. So this is electronic waste benefit philosophy, that we use electronic waste as much as possible. So now, as you can remember from the last 6 circuits, please, electricity can kill. Use safety precautions when you are working with electricity, however small the voltage or current would be. We expect also that you have experience in working with electricity, so make sure you have someone who can help you who has experience if you do not have experience in working with electricity. We also assume that you have prior knowledge of electronics. So please, this is not a lesson on electronics, it's a description of how these circuits work, and they are mainly for a specific purpose. Please keep all working environment clean. This is not a children's place when you are working with electronics because of small components. We also expect that you will be at least 10 years of age and above. If you would be under 10 years, maybe we'll be happy to hear from you, but normally we are looking at people who are in at least grade 5 and above. So, as we always say, this is a share, not an electronic lesson. Please, you have to have knowledge of electronics prior to attempting to do this, or get someone who can help you. And remember, use as much electronic waste as possible, because we want to recycle the electronic equipment that has been thrown away and clean up the environment. Yeah, so there is always better ways of doing this, but this is what I have done on these particular ones, and we expect that you can improve, you can make it better, you can adapt it, you can modify it to suit your purpose and needs. And these circuits are best according to my experience and what I have seen. They are best for training and learning. You can use them as training and learning aids. You can also use them at home, and even industrial, like this alarm. This is a home alarm. It can also be a premises alarm system. Very simple, straightforward, and very effective as well. On this one, please, we are not using programmable equipment, so the programming equipment may not be necessary on this one, except you need a computer or laptop to draw up schematics or to produce PCBs. You will need power supplies for testing, of course. You will need electronic components from electronic waste. If you have to buy components, you can also do that, no problem. Ferro boards or breadboards for you for the testing. Soldering iron and solder wire, of course. Multimeter, electronic equipment, of course. Oscilloscope maybe not necessary on this circuit. Logic analyzer, yeah, you may try logic analyzer, but a meter will do very well, because this is a normal digital electronic circuit. Software, not for programming, but maybe free PCB making or PCB software. You can download Proteus, the one that I've used as a trial version, or you can use your own simulation software. Yeah, the micro no, Flowcode no, and we would require you to actually keep the circuit maybe as simple as you can. And last but not least, we expect to have your time, to have your patience, to have your passion and your dedication. Thank you. I hope you enjoy your electronics. So let's go on again to our circuit. Prior to this, before I was explaining, you can here also see that we have the security key, which is the important part of the security system. And remember also that any sensor, like this sensor here, and that sensor, and that sensor, and this one sensor, are break circuits. They are break circuits. You need to have a break circuit in a security system because, as I have always said, security systems should be fail safe. So it's better that a circuit breaks and always would actually be in alarm position until you fix a problem. So that's why it is a break circuit, because things tend to break anyway. Unfortunately, well, the circuit is a bit big and it's not very visible. I'll actually zoom section by section, but you can see that this is repetition of the same circuit. This circuit and that circuit and that circuit and that circuit are plus minus very identical. The only difference is this circuit is going through a delay timer, and these circuits, these other three, zone 1 to 3, are going straight to drive the siren. Right, and below here you will notice that there are circuits. These are examples of how you can create other gates using some gates, like this exclusive OR gate. You can use it to produce a NOT gate. This is a NOR gate, sorry, exclusive NOR gate, not exclusive OR. This is a NOR gate. You can use it to produce a NOT gate. The NAND gate as well, you can use it this way, the connection, to produce a NOT gate. This is the standard NOT gate. And this setup here with 3 logic gates here, you can actually wire it this way to produce an OR gate. And this 3 logic gates, 1, 2, 3, with an OR gate, you can produce an AND gate. Right. So before we do this, we'll go for a simulation to see how this circuit actually is built and how it behaves in active state. So we go for a simulation. Hopefully it's feasible enough. Well, maybe I might as well just take out this bottom logic gates, but anyway, no problem. Okay, I'll zoom section by section as we go along so that you can actually see. Right, to start with, you have a security switch here. In this position, it is actually an alarm in on position. So let's switch off the alarm before we simulate. And here we have a switch that I've used here. This is basically for simulation purpose. Otherwise, this switch is not there in the actual circuit. So I will simulate first the entry door. So I switch to entry door. As you can see, it has gone to entry door, which means these other zones will simulate it later, the other 3 zones. So I'm simulating zone number 4. Right, I've also used a motor to indicate a siren running. So because this one was not actually producing any sound, but for visual purposes we'll use the motor to indicate sound. that is the siren running. And then right, so I've used one section of the zone circuit, which means the zone circuit has got this sensor, which can be a magnetic switch or a motion sensor. And then you have this gate, and that gate, that gate, and that gate, and that gate, and a latch here. Remember, this is a simple NOR latch, a set reset latch, which you can use building. You can build it using simple logic gates. Remember, there is another one which uses NAND gate, and you can actually use that one. But remember also how you can configure it. That will be if you would want to improve or make it in a different way. And here also there are the resistors for adjustment of time. You can adjust this resistor to adjust to change the time that will allow you to go out of the premises before the alarm is actually violated. This resistor will actually determine the time you require to enter the premises before the siren starts to sound. So every entry when the alarm is active is a violation, and you must activate it using the key switch or the security switch. And this timer here, this logic gate and that logic gate are basically there to time the exit and the entry. So now let me zoom it, and you use these capacitors also for timing. The capacitors that I've used, well, you may actually change them depending on the seconds that you require. Basically, you need about 10 seconds to go out, and even the coming back, you might be actually also 10 seconds or so. Right. Now, so our circuit will actually also have indication. This LED will actually indicate that the alarm is now on. This LED will actually indicate that the alarm is active. That is, any violation will actually trigger the alarm. If it is in the entry door, it means you have those delay seconds, and then the alarm will start to sound. And then the other LED is actually to indicate that violation has taken place, and also it indicates the zone that it actually where the violation is happened. So these are the main basic areas of the alarm. Here the oscillator is just to switch on and off the siren, because we can't run it continuously. So yeah, that's plus minus what this circuit is all about. So let's go for our simulation. Let me just zoom it complete. I think we have seen this one. I have explained it on the other circuit for the main circuit of the alarm. Right, so this is basically for simulation purposes only. As you can see, as is, this capacitor is discharged, because this security switch is actually bringing this negative or ground to this point here, which means ground here and ground here via this resistor. The capacitor is discharged. Now this also capacitor is discharged. Why? Because here you have a low output, so here is actually ground, which also brings ground here and ground there. So this capacitor is discharged. So you have a low and a low here. So that's the condition that is here. Now coming to here, this capacitor is now charged, because we have an oscillator here, which is having actually an output of a high here, which brings a high here and charges this capacitor. So this capacitor is charged. So you have a condition of a high here and a condition of a low here. Right. So this is the state in which the the alarm is the zone sensor is actually in non-violation, which means there is continuity. You bring a low here, and then here on this one is actually a low. Remember our logic gates. This is basically a NOT gate, and this one is a NOT gate, and that one is a NOT gate. I have not taken out at least our logic gates. So here is the arrangement. A NOT gate is one side having ground, and then the other side is a condition that comes. So you have a NOT gate here on an exclusive NOR gate. So that is a NOT gate, that is a NOT gate, that is a NOT gate. Right, so what happens? Suppose the alarm is in off position, and this is the entry door position. As I have said, this zone is number 4 on our main circuit. This zone here is number 4. I have configured it to be zone number 4 because it is in the entry position. So, and remember, this switch is just there for simulation. It's not a permanent switch. Is not supposed to be there in normal operation. Right, so it is an entry door zone. So what happens is the alarm is in off position. So you are coming on and going out. I wonder why. Because I know it must be in action there on this LED. Okay, if I switch it on and I switch it off. Okay, right. Sorry. Well, I'm looking at the wrong LED. It's actually this one. Check this LED here. What happens to this LED? If I open the door, this LED is going on, right? And then I close the door, it goes off. So the alarm is in off position, so it should not actually do anything. I can open the door and keep it on, open, and the LED will just indicate that this zone is violated. But so because the alarm is in off position, nothing will happen because this latch is actually set. So the door is open, the LED indicates that the door is open. Even if it is a window, it actually also indicates that the window is open. So it is a zone indicator. I can close and then it just close. Okay, so how does that happen? Now you have a low here and a low here, because this is a NOT gate. A low here will bring a low here and a low here. So this part here is the set input, and this is the reset input. So when this latch is reset, you have a high here and a low here. Now, so you have a low here, meaning this latch is reset, and this is a NOT gate. So a low here will actually bring a high here. As you can see, it's red, and then that high goes there, and here you have a low because this one now is an OR gate. And what will be the condition of this one, of this state here? This state here is actually coming from there. It's actually coming from there, from the security switch. The security switch brings a low here, brings a low here, discharges this capacitor. So on this point here, it's a low, so it's bringing a low here, and this low would actually not matter because it's a I don't care scenario here. It depends on this condition here, which is now a high into a NOR gate. It means you have a low, and a low here. We are now looking at the other input. A low here will depend on this input here, and this input is actually, well, because it is a NOT gate, remember, because this is a low, right? So this is a NOT gate, this is a NOT gate. So here is a low as an input, so a low will bring a high here, and a high here will depend on the other condition, because this is a NOR gate, an exclusive NOR gate, sorry. You have again the input from this side here, which is actually a high here. Well, you can trace it. You have a low here, bringing a low there, a low there, and a low there, because this is a NOT gate. Now you have a low here. This should be a high, because that one is a NOT gate. So remember, this is a NOT gate, this is a NOT gate. A low here, we have a high there. So a high and a high, exclusive OR. If you have a high and high, you have what? A low output. If it is a NOR gate, exclusive NOR gate, a high and a high here will give you a high. So you have a high there. So this latch is actually reset. So when it is reset like that, it means you have a high here. So suppose I open the door. When I open the door, it means here becomes a high. This is a NOT gate. A high here, bring a low there. Let me zoom a bit. A high here will be bring a low there, because this is a NOT gate. And then this is a NOR gate. A NOR gate, remember, our security switch is still off there. So here is a low, then a low and a low here will bring a high there. You can follow the colored dots, the blue and the red dots. Here it brings a high there. This is a NOT gate. A high there will bring a low there. This has not changed. This condition has not changed. This is a NOT gate, and it depends on the condition of this one. This input here, which is a low, so we have a high there. So it is still here a high there. So a high there, this is an exclusive NOR gate, so it will depend on the condition of that one. This one has become low, so a high and a low on a NOR gate will bring us a low. So a low there would mean that this latch will actually be set. Well, mostly it depends on the set input. So we have brought in a high there, and then this high there will actually set there. So you have a low here on the reset pin and a high on the set pin. So the latch is actually set. When it is set here, it becomes a high, and here it becomes a low, because this is a NOR gate version of a latch with the set reset flip-flop. So you have a low there, this LED comes on, because this is a positive supply, VDD 12 volt. If you want 5 volts, it's up to you. So now suppose I close the door, because I was opening the door. I close the door, it means you have actually reset to that previous description that I have said. It actually resets the latch. How does it reset the latch? You have a low here coming there, and then a low here and a high there, a high there, you have a low there, you have a low there, and this is a low, it comes a high, and then here you have actually now it's still there's no change. A low here, it means this is a high, and a high there is actually you have a high there and a high there. A high and a high will bring a high there. So this is now a high there will actually reset the latch. So this is what is happening. You are just coming in or going out, opening the door and closing the door, opening the door, closing the door. Nothing is happening. Suppose now I have to set the alarm. It means I have to operate the key switch. The key switch I operate. You can check here. The alarm is indicated that the alarm is now on, and it will give me time, because once I operate here, it will start to charge this capacitor, and that capacitor will actually give me time to actually go out. Okay, now let me first change here the value of the capacitance to actually maybe 1000 microfarads, so that you see what is really happening. Okay, sorry for that. Okay, now let's simulate. Right, now it's simulating. Right, so I want to go out and I want to set the alarm on. So what do? I switch on the alarm and this capacitor starts to charge. It will start to charge. Now it is discharged, but it is charging. And I think I've set the alarm, the capacitor too high. Yeah, now you see a positive is coming there. Maybe let me put it to 220 for the purpose of time. 220 microfarads to okay, just double the time. Right, okay, simulation. Right, yeah, now it is on. Right, you see it's now starting to charge, goes through gray and then it will turn red and it will actually indicate right here. So but we have not seen that. Okay, right, that LED is now on, indicating that the alarm is now active. So any violation will actually trigger the alarm. Let me start, switch off the alarm and then I start. On, the alarm is on, the alarm on indicating here. This one is off, remember, it will come on after this one is gone, high, to indicate the alarm is now active. These are the seconds now. Yeah, now it has gone on. These are the seconds of going out. By now you should have closed the door and gone out, because the moment you open this door, it means the alarm is now violated. So what do? Yeah, I've gone out, the alarm is now active. Any violation will trigger the alarm. So suppose I'm coming back, I trigger, you see this one, it has gone on, meaning there is violation there, and it will give me these seconds. These seconds are now, this capacitor is now charging. This capacitor is now charging. Now see, that one is now, the siren is ringing. The siren is gone off now, indicated by that motor. The siren is going off now because it has given me that time. So if I am someone who is a burglar and I don't know where this switch is, or I do not have a key to operate the switch, the alarm will go off. But during the seconds that I come in and I deactivate the alarm, I can just come and deactivate the alarm. Okay, deactivate the alarm, the siren stops. Okay, let's start over again. Alarm on, wait for those seconds. Yeah, I'm going out, I open. Here you see it does not activate. Alarm active, I can have opened and okay, alarm is now active. Now after some time, if I violate this alarm, okay, see now in violation, to wait for seconds. If I come and deactivate the alarm, it doesn't run the siren. Now, so what are we saying? We say you have a time, seconds that you have to go out, which you can adjust using the resistor. Not the way I was doing, adjusting the capacitor. Fix the capacitor value and then change the resistance value to adjust the seconds that you want. Maybe 15 seconds, 20 seconds, or whatever. And then also here on the entry time, you have to fix this capacitor and adjust the time you have to enter before you can activate or deactivate the security switch. This capacitor is basically for timing of how long this siren will run and switch off. The oscillator, please adjust as well. You should adjust these values of the resistors to actually configure the time of on and the time of off. The siren must run on for given maybe minutes and then switch off for a number of minutes, then start again until it is deactivated. So this is how this alarm would work. This is the basic building block of the alarm. The basic building block, the latch and the sensor circuit and the timing, security switch, and then the rest is sounding. Suppose now, let's say you now are having a panic a sensor or a window or any other sensor, a motion sensor or some kind which do not need the timing delay, no delay sensor. I go to this position now, which means this circuit here would be identical to the circuit connected to there, the circuit connected to there. So this is zone number 1, zone number 2, zone number 3. The diodes are there to actually give the OR function. Remember from our traffic light controller, this is an OR function, 3 input OR function. So what happens in that position? It means if I activate my, sorry, I'm trying to zoom so that you can see what is happening. Right, I'm in the premises. Now I want to go out. I activate the alarm. Give me seconds to go out. I can even go out. Right, I've gone out. Now I've gone out, and then after some seconds the alarm is now active. If I come back, or because now this is now not a door, an exit door. This is a window, or it's another door, or whatever, the kitchen door, or any sensor that you do not need delay. The moment I violate here, the siren must come on. So I violate here, you see, the siren will come on. The moment I violate, the siren will come on. There's no delay because this circuit is now coming through without any delay. Through here, no delay, running this oscillator. Right, the stopping is because of the processing. Something is happening behind, just the processing of the simulation. So the alarm is active, the alarm is on, and there is violation in that zone. So you have the same similar circuit on zone 1, on zone 2, except the active this LED and that resistor. You only place it on one circuit. It's just an indication of whether the alarm is active or not. This is actually displayed outside, so that you can actually see whether the alarm is active or not. This is also displayed inside or outside to show you that you have actually switched on the alarm. It's just an indication that when you switch on here or deactivate, it shows you whether with the position of the key switch. Here also this violation indication is actually there to show you which zone has been violated. This is actually inside or outside, where you can actually see when there is violation. So this is how this circuit works, and it's simple and straightforward. So this is our simulation. Okay, you can stop this one, so it will stop violation. The siren will stop because now the key switch is in off position. Deactivate the switch. So any other circuit will actually be similar to any normal alarm system. So please use recycled equipment. One thing also to note is you can use the TTL version of these logic gates, the 74 series, 74 ALS, 74 F74 HC versions of these logic gates. No difference except that the 74 series you power using 5 watts maximum, 5 volts. Some will go for 6 volts, but use 5 volts. These ones you can use up to 18 volts. The CMOS, the 400 version of logic gates, you can use up to 18 volts, but normally you would work within 12 volts. So now we have discussed our circuit on simulation, but this main circuit, as you can see, it's basically the same like our simulation circuit. This is how it works. We have your zone number 4, which is the entry exit door, with actually an indication there, and the alarm active indication is on this zone, and it's not on any other, meaning that the indication is, you can actually just use one, because you only need to know whether the alarm is active or not. Then the zone indication are on each circuit. Is for zone number 1, here's the indication, zone number 2, here's the indication, zone number 3, here's the indication, and zone number 1, 2, 3 are identical. The moment it is violated, when the alarm is active, the siren will go off, but this one is delay because it's an exit entrance door. Right, you can use the, remember, our electronic locking system to actually use for the security switch, or you can use a remote control, or you can use any other security switch system. You can, what you need here is just putting a low condition, or putting a high condition through disconnecting the low. And then here the circuit is the same. Adjust this resistors to actually change the on and off in time, which is duty cycle, basically. Right, I think that's plus minus the operation of the alarm system. Simple and straightforward. Thank you very much. Once again, feedback, please, you can email me, tauraimirimi@gmail.com. Thank you very much. Enjoy electronics.